Hi everyone, I'm Shivay and with me is Rohit. I hope all of you are feeling great after an amazing day at KCD Bangalore. Of course, I could not be there for yesterday, but I'm super excited to be presenting today's talk. And with me is Rohit. So we are going to be talking all about WebAssembly. WebAssembly is a huge craze going on right now, both in the cloud native and also in the serverless space. And we'll see that if you are not coming in from that background and you have traditionally been from a Kubernetes and a Docker background, how you can actually leverage WebAssembly to make the applications that you build even faster with the help of WebAssembly. So we're going to be demystifying a lot of the concepts regarding WebAssembly, and then you can see that how you can run them together. So very quick introduction about myself. I'm Shivay. I'm a WasmEdge ambassador, a developer relations engineer at Millisearch, and an organizer for KCD Mumbai. And over to you, Rohit.
So I am platform advocate at solo.io. So we work in the application networking and stuff. So I'm also running this many communities and stuff. So we are both of the one of the organizers for the KCD Mumbai also. Look forward to it. And if you want to check out the cloud native stuff, you can go to the cloud native talks. What will the agenda for today? So we will discuss like what is WebAssembly and then what it benefits in the cloud native, if it benefits to Kubernetes in which way, how Kubernetes benefits to Wasm in what way. So we will discuss everything, and then we will also look forward to the use cases as Shivay talked about. So yeah, see forward to. So what actually is a Wasm? Like everywhere they are talking about WebAssembly. What is the Wasm? Like people say it is just for the web. People say just on the browser, and you can go to the you can build some web thing and stuff. So if you have seen the websites like Photoshop, Figma, and there are like you have played that simulator, aeroplane
Flight Simulator.
Yeah, flight simulators. So if you go there, you see like there is like lot of thing happening, and you can like run it on the online. How is this thing happening? Like we think like how this was built and stuff. So this is kind of one of the thing you can talk about in the Wasm. And what actually is a Wasm? It is nothing but a binary instruction format for your virtual machine. So what actually it is? So you are working through the various languages, right? So you worked on the Python, you worked on the C++, Java and stuff. So we talked about the like one of many of the popular languages like C, C++, Rust, and Go. If you build the code in that and you want to compile it in some manner, like it will give you the binary instructions, and that binary instructions you can use as a Wasm. That is nothing but a compilation of one thing, and you can run it anywhere. So that is one thing you can talk about the Wasm, and that's what compilation target is, right? So that's what we talked about. So why actually Wasm, right? Why means why not? It is similar to the containers kind of a thing. So why Wasm? And many people has this misunderstanding, or we can see like it is myth, we can say, right? So they think like it is replacement for Docker. Anyone thinks that? So you actually knows Wasm, right? So it is nothing, but it is not like that. So that's why we are taking this session, and we will discuss what actually it is. So let's move forward. It is really efficient and fast. As you can see, you can run various things really fast because it is like you have Wasm Wasm thing is so small and lightweight. Like if Linux containers taking you like 100 seconds or something for that, it will just be in the milliseconds and 1 second. So that much efficient it is. And so moving forward, it is open and debuggable. You can directly go to the code and do the stuff. And it is also available on the open source, so you can contribute and stuff. So that is nothing but we will stay here. It is also available for the non-web platforms. It is not just for the web. So how, we will discuss it further. And yeah, open web platform, it is open source. You can go and check it out. If you want to contribute, you can do that thing also, right? Because it is one of the popular one nowadays. Since 2019, now it is Buzz. So you can really check it out. So it is secured, highly secured. How secured? You can go to the Wasm website also. There is really nice blogs and documentations are written. We will give you the some links and stuff. You can check it out. So moving forward, it is whatever we discussed now. So it is gist of it. As you can see, it is efficient low-level bytecode. If you see that machine codes we talked about, right? So that thing, and it is really portable, secure, and language agnostic, because it is like different language you can take and compile, and you have the compilation target. And think of it as a small, fast, efficient, and very secure. And has the stack-based virtual machine. It doesn't care about OS or your whatever VMs you are running on. So yeah, that's what we discussed. So yeah, this example I gave, right? So this is nothing but your WebAssembly. You have the Lightroom, you have the Figma, you run virtually, online, right, on the websites. So that is the thing. So this is how the compilation process looks like. I took it from the code cloud. So as you can see, C code is you have written some code, right? So then you can compile it using the mscripten, which is one of the popular thing in the Wasm. You can take it and you can convert that to the so it gives you the 3 types of file. It will give the .wasm, .js, and one kind of a file. So you can take this binary file and you can have the JS code also. So you can use it in the web, right? And if you want for the server, so what can we do? So let's talk about that. So as you can see, it is efficient, portable, low-level bytecode, but not bytecode, just not for the web. You can run it on the server. Wow, there is Wasm time, WasmEdge. If you want to know about the WasmEdge, he is the ambassador. You can talk about him. So the browser, there is a V8, there is a Edge, Warmer is there. There is in the containers you can use the Wasm, and also mobile applications you can build it. So how actually is Wasm in the cloud native? So that's what people is excited for, right? So as you can see, from the internet to the AI ML, it is used everywhere. As you can see, for the orchestration, there is a Wasm cloud available. There is your popular one, which is as assembly lift is there, Crustlet is there. What actually it is, if you don't know, you can search it. But you must have known these things like WasmEdge, then Open Policy Agent, OPA, everyone uses, right? So you can use the OPA to connect various things. I have that architecture also, you can check it. So we have the host, you have the proxies, right? So env filters are there. So which filters are there, we will talk about at the end. And there is libraries data, so there is a single store for that, and there is a so AI/ML is also introducing the Wasm, not just about AI. There is various startups in the Silicon Valley. They are talking about various things in the Wasm. So it is one of the trending one. You can check it out. So as I talked about OPA, right? So you can connect the CI/CD pipeline with the OPA, and then you can use the Spinnaker. You have the Kubernetes you want, then orchestrator, Kubernetes is a popular orchestrator, right? You can use that for the Wasm. Similarly, there is database, then there is a, so this is high level architecture. If you know about the Istio envoy and that, so you can go to the OPA website, Open Policy website, there you can check the Wasm documentation is available. And it helps you to connect with the filters of envoy. It helps you to build the multi-cluster environment of the Istio. So if you heard about the Istio service mesh, so it is also available, integrations are available. Similarly with the Elasticsearch and then other things. So as you can see, we have come long way, right, from the PC to the containers, and now we are talking about the Wasm. So there is various thing inventing daily, right? So Edge is there, there is a, so Edge also, there was a different Edge, now it is another Edge. So this entire journey, this is really nice documentation from the Cosmonic. I will provide you the link of this blog also. They have written entire document for the Wasm journey, like what actually happens, and they have like nice keynote also. So as you can see here, this is Wasm keynote. at KubeCon EU 2021. I will highly recommend you to check it out. It takes you through the journey, like how the Wasm is in cloud native, and how you can apply the various things inside that. So as you have like there is a hypervisor and there is kernel, right? So previously Docker, now also Docker is there, but how you can have the various things, like what is the lightweight things available for that, and how you can integrate the Wasm in Docker, and how you can introduce it to the cloud native. So why WebAssembly then? That is, it is like, as I talked about, efficient and fast, and it is really lightweight, and the company needs a solution where it can be lightweight and simply connections with everything. So that's why people are building the filters and integrations, right? So it is not just for like, if everything is available, then why to build new? So there is popular tweet also on that, so Shivay will talk about that. So as you can see, it is where WebAssembly is nowadays using for. So web for sure. Then there is serverless games we talked about. Then there is a plugin environment and containerization for sure. That's what we're talking about. And then there is the IoT. So also you can check the IoT edge connections with the Wasm and how you can build the stuff. So if you are the if you learn the love the Jetson Nano and Raspberry Pi, you can surely try it out. This is kind of a popular survey which tells like popularity of Wasm has increased rapidly, and it shows everything like how it is increased in the containerization. So you can check and see like how popular Wasm is. So moving forward, Shivay will take you through the journey of what actually is beyond the web. Yeah.
Yeah, so thank you so much, Rohit. And kind of Rohit has painted the picture of what Wasm is. And I hope that you at least get a basic glimpse of what it does and what it's capable of. So starting off as a browser technology of being able to make JavaScript applications run faster, we wanted to also see that how it could actually help you to run applications faster on the server side and in the cloud native side, right? That's the basic idea. So in order to be able to make your Wasm modules interact with your file systems, with network, or with sockets, we needed a way, or we needed a standardized set of APIs that the Wasm modules could actually interact with, and that kind of raise basically brought into WASI, which is the WebAssembly system interface. So a great way to understand this is, and of course, no WebAssembly talk is without this particular tweet by Solomon Hykes, who was the creator of Docker. He said back in, I think it was in 2013 or 2019, and there's like another tweet as well, and he said that if Wasm and WASI existed back in 2013 when Docker was originally created, there's no need for actually having Docker. But of course, that is a bit misleading, because of course today we are trying to demystify that you can you essentially need both Docker or containers and WebAssembly at the same time, and we'll kind of showcase why that is the case, right? So I spoke about WASI, and I spoke about that how WebAssembly needs those standard set of APIs in order to be able to make syscalls. So generally, whenever you look at a CPU architecture and you want any application to make certain requests to your operating system, so those requests will go through the operating system and they will make the syscalls to your kernel. And that is how you'll be able to make any application requests, right? So similarly, if the WebAssembly needs to interact with any file system resources or with networks or with sockets, you need those standard set of APIs. And that is what WASI allows you to do. And that enables you to be able to run Wasm applications on the server side and in the cloud native side. So a lot of the things that we'll talk about after this particular slide will be all related to WASI and how WASI enables you to run the Wasm workloads inside of cloud native, inside of Kubernetes related environments. So of course, coming to the biggest point, biggest talking point for today's session, of course, a lot of us have spun up Linux containers. How many of you have not spun up a Linux container in Docker? Anyone? So I assume like the 100% of the audience, above 30-40 odd people over here have done that, right? So of course we are very well versed with Docker. So why bring another standard, right? Because generally your journey as a cloud native developer would be you learn Docker, you learn Kubernetes. So why introduce a new thing that can probably replace Docker? So one of the things that Rohit kind of touched upon was the speed, right? So generally, if you are having a lot of dependencies in your image, it will have a very large startup time, and it will also be very large in size. So if you're specifically looking at edge use cases where your entire system itself is very limited in terms of the resources, also in terms of the compute itself, running these large Docker containers can actually take up a lot of time. And the thing with Wasm is because it is a very low level bytecode, and it does, I mean, it's even smaller than containers. So typically your size of these Wasm binaries is like 10 to 100 times faster or smaller than your standard containers. And here's one particular example where we had basically a machine learning model. It's a very popular model, and we kind of implemented that model with both Docker and with the help of WebAssembly. And you can see that the model size and the entire container size for Docker is 39 MBs, whereas with WebAssembly it's just 3 MBs. And the startup time that you took for being able to run these containers has also a very huge difference. So the cold start time that you get with these Wasm binaries or the Wasm models is a lot faster, or it's very less as compared to your Docker. So that begs the question that why not just replace WebAssembly containers? I mean, why not just replace the Linux containers with WebAssembly, right? That's probably the biggest question that all of you might be having, because it's so small, it is also so much more faster. Why not just completely replace and I mean, the last 10 years we celebrated like 10 years of Docker. Why not just take that away and just use WebAssembly at all times? So the reason, the fundamental reason behind that is that WebAssembly ecosystem and the tooling is still very new, right? So although it has been there for the past like 3 to 4 years, the developer tooling around Wasm is not that great. So when it comes to doing a lot of different operations such as socket operations, or even for that matter like network operations, those are not very well supported. So a lot of times you'll actually get frustrated in trying to actually do that. And WasI has a lot of different proposals being run right now by the Bytecode Alliance. So the Bytecode Alliance is like the body behind WebAssembly. Like we have CNCF. So Bytecode Alliance is what basically deals with all the latest proposals in both WebAssembly and in WasI. So a lot of the WasI proposals right now for bringing support for socket connections, for networking capabilities inside of WebAssembly are still being written, and they are in the process of being implemented right now. And of course there is the component model, which I'll not go too deep into it, but the general idea is that if you want to build production grade applications and you want to just use WebAssembly, it will not be the case. So what we kind of propose is that you may be able to run both Linux containers and WebAssembly modules side by side. So your Linux containers could basically take care of all the heavy lifting that requires, such as making those syscalls, making networking calls, whereas the WebAssembly containers could actually be used for small applications that need very quick inference time, that need to be set up very quickly. For example, let's say you have a full stack machine learning application, right? So within that entire application, whether it's loading up of your data and making some HTTP calls, that could be taken care of by the Docker containers, whereas the WebAssembly modules could just run the inference function, because the inference function is required to be very quick. It will do the inference in very quick time, and then your Wasm module can then stop running. So it's that kind of an interaction where you use both of them hand in hand, and they both benefit from the extensive tooling that you have with Docker, and you can leverage the quick cold start time that we get with Wasm to be able to run some of those high throughput functions that require you to have very less start time. And this is one of the goals that, of course, we want to see, that within, let's say, in the entire Kubernetes space, how you can actually run both of them side by side. So in this particular diagram kind of showcases all the way moving from Kubernetes, then going into the CRI where we have containerd, and today's example in the demo will be showing how you can actually do that with the help of containerd. And of course, the containerd of course does support, there are shim APIs that support Linux containers, but we'll also see that how it can support WebAssembly as well. And here is like the introduction. So very recently, in the past like few months, a lot of development has been going on, especially with Docker as well. So now Docker actually supports you to be able to run Wasm workloads directly, and you can use the standard Docker commands like docker build, docker run to run WebAssembly modules. And you can also now run WebAssembly modules directly in pods instead of your Kubernetes clusters. And how that kind of started was that typically you have containerd shim APIs that can interact with your containers, and we basically created containerd Wasm shim. So this comes from a project called Run Wasm, which provides you specialized shim APIs that can interact directly with Wasm modules, and you can directly run them inside of your Kubernetes pods. And the icing on the cake is that you can actually run them side by side. So think of a cluster where you have, let's say, your main control plane, and you have 3 different other nodes. 2 of them are Wasm worker nodes, and 1 of them is a standard Linux worker node. So you can actually accomplish this using today's architecture, and we'll be showing you now a demo of how we actually accomplish that. Now, before we move to the Kubernetes demo, I just wanted to quickly also show you how you can run the standard Docker commands in order to make Wasm binary execute inside of a Docker container. So if I just quickly go over some of the previous functions that I wrote, what I did was that I created a Rust function, and I added the Wasm 32 WASI target. So that means that it will basically take your Rust modules and compile it down into a WebAssembly bytecode. And then I ran like cargo new Wasm container. So this basically set up a new code for me. So if you quickly take a look at what is there, you can see the source file. So if I go to the source file and take a look at the function, so let's take a look at the main function. It's just a simple hello world function that we'll be deploying. So I'll go back to my Wasm container module, and over here what I'll do is that I will basically use the docker buildx command, and the idea over here is, and what I'll do is I'll give it a name of KCD Bangalore because we are running a demo over here. So idea is that we are using the buildx command, and this buildx command is a specialized Docker build command where we are giving it the platform WASI so that the Docker environment knows that we are actually dealing with a Wasm module, and we'll go ahead and build our container, right? So we'll go ahead and build it, and then we'll try to run it. So let's go ahead and try to run this. So again, I'll just give it over here Bangalore, and it gives you a hello world. So what this quick demonstration shows that we are able to package our Wasm modules inside of Docker containers and then run them, right? If you take a look at my Docker containers, you can see the KCD Bangalore one which I just ran, including both the image and the container that just ran. Now, of course, we are slightly out of time, but I'll be sharing this gist file with everyone, and this kind of walks through the other aspect of being able to run your Wasm workloads and your standard Docker workloads side by side. So what I did was that I set up a standard K3D cluster, Kubernetes cluster, and if you take a look at the nodes that I have right now, so what I spoke about was like setting up 2 different, one second, let me just ensure this works properly. Let me refresh, and so while we are just waiting for it to load, what I mentioned was that we'll have 3 different nodes, 4 different nodes. One is the master control plane node, there will be 2 Wasm worker nodes, and there will be 1 Linux worker node. So if you take a look at my current, and I'll quickly just walk through the set of current pods that I have over here. So you can see that right now I have 3 different Wasm nodes that are running, and there is this my app, which is basically just an Nginx container that I ran up from the Nginx image for Docker on Docker Hub, right? And the way that you'll essentially do this is that first we'll start off by building a K3D cluster. Now, because we're slightly running out of time, I'll not show the end-to-end demo, but you can just follow the steps mentioned in this gist, and you should be able to very easily actually accomplish this. So what we're doing with this cluster is that you'll see that we are providing it an image. The Labs is basically a Microsoft subsidiary which mainly works with containerd shim. So the entire RunWasm project was basically brainchild of their innovation, and we are creating 2 different Wasm related nodes over here. Then what we can do is that when we do get nodes, kubectl get nodes, you will see those agent nodes spun up. And then you can actually also take a look at the runtime configuration, right? Because of course, how these worker nodes are being able to run your Wasm workloads is with the help of the containerd shim. So in order to see whether those are actually there, you can very easily just run this particular command called docker exec, which will go into one of these particular nodes. And let me just quickly check whether this works. Okay, so we can probably ignore that, but the idea is that this particular node will actually go inside of one of your nodes, and when you run this particular command, which is basically looking for the containerd configuration, it will basically show up all these different containerd shim, run c, containerd shim slight, and containerd shim spin. So slight and spin are basically two different iterations of being able to actually run your Wasm workloads inside of inside of Kubernetes. And then of course you can label your nodes over here with this example. And finally what you can do is you'll have to basically define a runtime class. So this runtime class is very important. It's one of the most important steps, because this is a step where you'll basically go ahead and define that what type of Wasm workload you're actually running. So there are different ones supported, Spin, WasmEdge. So there are like different ones, and if you want to get to know more about it, feel free to contact us. Once you have done that, what we'll do is that we'll create a deployment over here, and this is like one of the YAML that kind of showcases the entire deployment. So in this example, we are using a Spin application. So Spin is a microservice-based framework for being able to create microservice serverless WebAssembly-based microservices. And once we do that, we can go ahead and deploy it. And you can see the deployed version that we have. So we can actually just simply run this particular command, which is actually running it locally. So I'll just actually go ahead and copy our run command over here to basically test it out, to showcase that it's actually running. So in this case, you can see that it says hello world from Spin, so it's a very simple application. And if you also want to scale up your application, so you can create replicates, so we can define those as well. So in this case, it will go ahead and create additional replicates for you. But this is a quick demonstration of how you can actually create Wasm workloads and run them inside of your Kubernetes workload. And as we showed that there were two different nodes that were running the Wasm workloads, and there is one that was primarily built for being able to run like Docker containers. So you can actually run them side by side inside of your Kubernetes cluster, both side by side. Now over to Rohit to kind of finish off with the rest of the slides. Yeah. And this is by the way the gist. So feel free to scan it. We'll also finally give you the ability to scan the presentation, so we can move forward.
Yeah. So we will run fast through it. Actually, it is just a use cases we will talk about. So you can use the Envoy proxy. You use the Envoy proxy, right? You know about Envoy proxy. It is one of the popular and richest proxy available, right? So it also Wasm as a custom filter. So what happens? So normally, if you don't have the Wasm, you have to develop and build to the C++. If it is written, then you have to develop, build, go through the stages. But with the Wasm, what happens? So as you can see, extended proxy with the WebAssembly, it is secure, it is sustainable, speed, and as you can see, Wasm expands to any languages. So if it is written in a C++, you can directly change it to the compile target, and every time you don't have to recompile, restart your proxy, you will directly go and do the run anywhere kind of a thing. So this is kind of a nice documentation. You can go with the state of WebAssembly in Envoy proxy. So where they talked about various things from the 2019 to 2023. So yeah, as you can see, today's talk was about the power couple, right? So as Linux containers is for the Docker, and same for the WebAssembly, there is Assembly Hub and various things available. You can check it out. And as we move forward, this is one kind of nice thing you can try. It is available. We will share the slides so you can go through it. So this is multi-cluster architecture which we normally do. Like you have the EKS cluster, then you have the local clusters also, right? Then you connect and do the deployments and canary deployments kind of a thing. You have to access the web page which is downtime, and then you have to access, then you launch new one. So that kind of a thing also you can do with the Wasm. It is kind of lightweight you can use. So we will provide you the slides. So as you can see, this is the WebAssembly Hub. You can try it out. And as you see, what is WebAssembly? This is one of the, it is not available anywhere. So you have to click the picture for it if you want to learn about the Wasm. So it tells everything about the Wasm.
So just a quick shout out that there is a lot of WebAssembly events that are going to be there throughout the month In fact, there's going to be a few WebAssembly related meetups in Bangalore itself on 10th and 11th June. So if you're from Bangalore locally, feel free to join those. These the company behind Fermion, which is the company behind the Spin project, they are coming up. So there will be a lot of serverless and cloud native WebAssembly being talked about. So if you're from any of these cities, all these meetups are being organized. And that, Phil, with that, we'll basically conclude our talk. And if you want to take note of the slides, please feel free to grab
Thank you for having us.